For my project, I will be looking at the physics of hot air balloons. I will attempt to answer the question, what role does physics play in making hot air balloons fly? Next, how does a hot air balloon work? The basis of how the balloon works is that the warmer air rises in cooler air. This is because hot air is lighter than the cool air, as it has less mass per unit of volume. Mass can be defined by the measure of how much matter something contains. The actual balloon has to be so large as it takes such a large amount of heated air to lift it off the ground. To help keep the balloon in the air and rising, hot air needs to be pushed upward into the envelope using the burner. The burner uses propane gas to heat up the air inside the envelope to move the balloon off the ground and into the air. The pilot must continuously fire the burner at even intervals throughout the ride to keep it stable. The hot air does not escape out of the bottom of the balloon because hot air rises, and the buoyancy of the air keeps the heat rising up. Buoyancy is the force exerted on an object that is immersed in fluid, and air is a fluid. The pilot utilizes this to fly and direct the balloon to the destination. A hot air balloon has very simple controls. To move upward, the pilot opens the propane valve, which lets propane flow into the burner, firing up the flame and heating the air in the envelope. The wider the valve, the bigger the flame, the faster the balloon rises. To move the balloon downwards, the parachute valve at the top of the balloon is what is used to bring the balloon down towards the ground. It allows for the hot air to escape and decrease the inner air temperature, causing the balloon to descend. Just like a sailboat, the pilot can maneuver horizontally by changing the vertical position of the balloon and catching wind that is blowing in the desired direction. Now, on to how physics plays a role in this. The hot air inside the envelope is less dense than the cooler air surrounding it. The difference in density causes the hot air balloon to be lifted up off the ground due to the buoyant force created by the surrounding air. The physics principle behind this is Archimedes' principle. This states that any object that is suspended in a fluid is acted upon by an upward buoyant force equal to the weight of the fluid displaced by the object. In any object, there is a center of buoyancy in the center of the volume of the object. The upward buoyant force is equal to the weight of the displaced object's volume. For a hot air balloon, with air being the fluid, the upward buoyant force acting on it is equal to the weight or mass of the cooler air surrounding it, that is displaced by the hot air balloon. Since the air inside the envelope is heated, it is less dense than the surrounding air, which means that the buoyant force due to the cooler surrounding air is greater than the weight of the heated air inside the envelope. And for the balloon to take off, this buoyant force must be larger than the weight of the heated air, plus the weight of the envelope, plus the weight of the basket, plus the weight of the passengers and equipment on board. As a result, the hot air balloon will experience sufficient buoyant force to completely lift off the ground. The weight of the hot air balloon is more concentrated near the bottom of the balloon, at the location of passengers and equipment, so the center of mass of the hot air balloon is always below the center of buoyancy. This ensures that the balloon stays stable and upright during the flight. In conclusion, hot air balloons use physics principles to stay in the air. So if you ever find yourself floating above the ground in a huge balloon, remember that physics is making it possible.